A very good morning. This is Mohammed Hani from second CACB section, and the topic for my presentation is hypothesis testing comparing two sample means. So as we move to the question that is given, the means of two large samples of size 1000 and 2000 members are 67.5 inches and 68.0 inches respectively. Can the samples be regarded as drawn from the same population of standard deviation 2.5 inches is the question. So, first let us understand what are the key concepts that come under this question. So, first we have to understand the difference between the population and sample. See, population is like entire set of data. Here, example is given as heights of all individuals in a country. Like for example, if you consider any country, then heights of all the people who are living in the country is considered as a population. And what about sample? Sample is like a subset of the population, heights of only particular these individuals, this state individuals, that city individuals, this and all come under sample. And what does sample mean? The average value of a sample. That is, sample is a subset. So in that, what is the average? This is called as sample mean. And standard deviation, a spread of how, a measure of how spread out the data is in the population. See, like in the population, how is the data spread? This is what explained by the standard deviation. And hypothesis testing, a statistical method to test whether hypothesis about a population parameter is supported by the sample data. So given data is, first they have given two samples, and the first sample size is 100 and mean is 67.5 inches, and second sample is 2000 of size and mean is 68.0 inches, and population standard deviation is 2.5 inches. Hypothesis formulation. So now we'll understand the hypothesis. H naught, that is null hypothesis. What does H naught indicates is that the two samples are drawn from the same population. So mathematically, H naught is mu1 equals to mu2. Then we can say that it is null hypothesis. And what if mu1 not equals to mu2? Then we can say that they are not belonging to the same population, and ultimately we call that aspect as alternate hypothesis. That is H1. So this is a two-tailed test because we're testing for inequality. Yeah, that is what we are understanding. Like the two samples are belonging to the same population or they are not belonging to the same population. This is what is called as two-tailed test. And test statistic Z test. What is Z test? For Z test, we have a particular formula called Z is equals to x1 bar minus x2 bar by root of sigma square by n1 plus sigma square by n2. So what each terms determine here is x1 bar is mean of sample 1, x2 bar is mean of sample 2, and sigma notation is what standard deviation, that is population standard deviation in this context, and n1 n2 is the size of sample 1 and sample 2 respectively. And now we will substitute our given values in that particular formula. So we have x1 bar equals to 67.5 and n1, that is size, equals to 1000, and x2 bar is 68.0 and n2 is 2000 and sigma is 2.5. So now we'll compute the z score. We'll just substitute all the values just that we have discussed now. And on substituting, ultimately we get the value of minus 5.16. Now we'll understand, we'll make the decision making here. So firstly, significance level. Typically 0.05 for a 95% confidence level. This is a fixed value. And critical Z value, plus or minus 1.96, based on two-tail test. It is already fixed value. Now we'll apply the Z value that we have got here. If Z bar, so basically we got minus 5.16, right? But here we have modulus. So modulus, what does it do? It converts the negative value into the positive value. That is 5.16. So 5.16 greater than 1.96. That is reject the hypothesis, null hypothesis. And if it is less than or equals to 1.96, then we have to accept the null hypothesis. But the thing is, here we have got 5.16, which is satisfied the first condition. So we will just reject this hypothesis. So, in conclusion, the interpretation is that the Z score falls in the rejection region, and there is sufficient evidence to conclude that two populations are not drawn from the same population. And final answer is that the samples cannot be regarded as drawn from the same population. That is, they are drawn from the different population. And thank you for your patience listening.